This is the most famous image in all of mathematics. Its name, the Mandelbrot set. So what is it and how can we generate it with code? First, we need to know that the Mandelbrot set is something called a fractal. A fractal is simply a geometric shape that has infinite complexity. One is usually made by generating a shape and then repeatedly applying a rule to that shape, with itself as the input, meaning a fractal is recursive. If that didn't make any sense, we can take an example. This is Koch's snowflake, and it's one of the most common fractals. The rule we repeatedly apply here is that we take every straight line and add a triangle to it. We do this every iteration. So this is the starting shape, a triangle. After one iteration, then 2, then 3, then 4, and so on to infinity. This is a fractal because it's infinitely complex. Assuming our computers had infinite memory and could run infinite iterations on Koch's snowflake, we could zoom on this shape forever and keep seeing new detail. One of the most beautiful things about fractals is how such simple code can generate such complex results. My code for creating Koch's snowflake is little over 60 lines. This is because all it does is recursively draw triangles on its previous shape. The most complex part is figuring out the position of the third point on the triangle it needs to draw. The Mandelbrot set is different from Koch's snowflake because it isn't self-similar, kind of, meaning that part of Mandelbrot set doesn't always look the same as the whole fractal. With the Mandelbrot set, we work in the complex number plane, which means that the x-axis is replaced by real numbers and the y-axis is replaced by imaginary numbers. An imaginary number is just some multiple of I, where I squared equals -1. A complex number is written as a plus bi, where a and b are real and I is imaginary. We can plot complex numbers on the complex plane like so. The way we generate the Mandelbrot set is we iterate through every point on this complex plane, every value of c, and we repeatedly apply the formula of z of n-1 equals z of n squared plus c. We repeat this formula however many times, say 100, and if the magnitude of z never exceeds 2, we consider c part of the Mandelbrot set. We say that it is stable and we colour it white, for example. For any value of c that does escape the bounds of -2 to 2, we colour it based on how many iterations it took to do this, or how unstable it is in other words. And that's how we create this stunning image. It's infinitely complex and beautiful, whilst coming from such simplicity. I mean, this only took 35 lines of code to create. Look at how incredible it is. So that's Mandelbrot set. I hope you enjoyed and learnt something. PS, wishlist my game on Steam.